Here we have a student who is sitting on his stool, which is 0.7 meters off the ground. So that's our value for height. And presumably he has some initial velocity of 0, and we know that we have our acceleration due to gravity at 9.8 meters per second squared. We don't know his mass, but we'll see why that's actually not necessary for this question. So this is a conservation of mass question, so we know that his starting energy, which is simply gravitational potential energy, is going to be equal to his kinetic energy, which is what he ends with right before he hits the ground. So we can expand this a little bit here. mgh is equal to 1/2 mv squared, and we'll see that these m's are going to cancel out. Now I want to rearrange and solve my equation for v, velocity. So that's going to be equal to the square root of 2gh. So we can see here why we don't need to know the student's mass to be able to solve how much kinetic energy he had after falling off of the stool. So we can substitute our values, 9.8 newtons per kilogram, or what units might make more sense here would be meters per second squared. Meters per second squared times h, 0.7 meters. After solving that, we get a velocity of 3.7 meters per second. So James hits the ground at a velocity of 3.7 meters per second.